Yes, hi. I just wanted to follow up on what I did the other day because I was looking at the sample size calculation. I was prepping for my one of my classes today, and I'm like, and I found this old calculation that I used to do for sample size, and it does not involve. It's not the same as the one that I was talking about the other day, where we needed the power, et cetera. But this is like a simpler estimation, and this one fits in well with the assignment. So I think this is what was done here. So here's an example where we have portions, and again, we're trying to calculate the sample size based on a margin of error. Now, for the first one of the questions that the professor asked was, what is the margin of error? What is the sample size necessary if you have this margin of error 0.005, 96% confidence interval, but she said that the P and the Q are unknown. P is the probability of success. Q is 1 minus P. That's just short for 1 minus P, the probability of failure, but they're unknown. And so this gave me a bit of a pause here because I would think when you're unknown, you use your best estimate, which is 50-50. I mean, that's what I would use. But again, it's hard to say because when I did the problem, I didn't get one of these four answers, but I came pretty close. So the question would be, what did this professor use for the expected value? Again, if you don't know something and you're doing using a binomial, so this is a binomial, a normal approximation of a binomial problem. And when you're doing that, when you don't know something, you assume it's what's the expected value, and I would just assume the expected value is 0.5, the average, right? If you flip a coin, it's 50-50. But then again, I don't know what this person was thinking. So I use this equation. So this is basically a rearrangement of an equation for the proportion. Now, as I mentioned the other day, one of the problems that I had with the equation that was used was it was using the standard deviation rather than the standard error in making a calculation for a confidence interval. So we use a standard error when we're making estimates from the sample to the population. So this was using the standard deviation, and the standard deviation is square root of P times Q over N. If we play around with that and rearrange our equation for our confidence interval, we can isolate the N. And that's what basically this is done. It's just isolating the N on one side. So it's N, which is the sample size, is the square of, not square root, square of whatever the Z value is associated with this 96% confidence interval, divided by E, which is your margin of error. And then the probability of success, these are estimates with the little hats. So to get this value for 98% confidence interval, 96% confidence interval, so it's right here, right? So this is the mean. And then with 96%, 100 minus 96 is 4, which we have to divide in 2 since it's the confidence interval. Confidence interval surrounds our point estimate. So if you look things up in a table, you're looking at whatever Z value is associated with this end right here, right? So it's the accumulation of the distribution from left to right. So that includes this 96% plus the remaining 2%. So that's what I looked at 98% there, and then I'd go to a table. And so here, this is a table that shows you all the values. And then what's in here is the cumulative distribution from left to right, as you can see from this nicely drawn picture. And we want 98%. And I find this is 0.98. That's pretty close, 0.9803. That's 2.06. So 2.06. That's what I put in here, right? So 2.06 and up divided by 0.005. That's my margin of error because that's what the instructor said, right? She said the margin of error is 0.005. So that's the difference that we're looking for. And then square that quotient. And then here we do P times Q. Again, I'm estimating it as 0.5. I get 412 squared times 0.25, and I get 42,436. It's close, right? It's close. So it would be one of these three. I'm not really sure which one, what exactly she used to get these. So it would probably be this will be the closest one. All right, so the next one was here, the proportion P was specified, so that was good. It was specified as 92%, right? So 100 minus 92% is 8%, right? So now this was easier. Margin of error 7, 95% confidence interval. The Z value associated with that is 1.96. If you don't know that, you should memorize that. So we got 1.96 divided by 0.07. We square that, multiply it by P times 1 minus P, 0.92 times 0.08. And I get 57.7024. Whenever you're estimating sample sizes, you always round up, regardless of what the value is here. You round up to make sure you have enough power. So this would be 58. And that one I did get. Here's how it's B. All right, so that was correction. I apologize for any confusion yesterday, but I take my statistics really seriously, and I prefer the calculations that you would see in my textbook, but this works. All right, it's a good estimate. Here you go. Thank you.